Hello everyone. I welcome you all for the lecture series videos of mechatronics and automation. In the previous video, we have discussed about the derivative mode. In the derivative mode, we learned that the derivative mode is not alone used because of the steady state error and a few uh, output responses of the mode also we have discussed. So in this video, we are going to discuss about the integral mode. So integral mode, the name itself indicates it is the output is the integral function of the error. So let us have and discuss about the integral mode. So as I told you earlier, the integral mode which produces the control function which is proportional to the integral of the time with respect to the 0 to the t, that is time value which is extended to some time period. So we know that the constant error will produces increasing the correcting signal. So it continues as long as the error signal persists. So the rate of error or the rate of change of the controller output is proportional to the integral of that error signal. So here we have some disadvantages, that is it tends to make the system is unstable when the responses, that is the change of error is very slow, and few applications is also there, that is where the time lags are short or the reactions are fast. For example, constant supply of air temperature ventilation systems, we may use this kind of integral signal, and this is the output of the signal which follows the mathematical equation, that is change in uh, that is in the output of the error signal, that is the integral function of the error signal with respect to the time is equal to the error signal amount of or proportional to the amount of error signal. So when you remove the proportionality, you have to introduce the constant of proportionality, that is ki. So ki is the integral constant. So if you are integrating with respect to the time, with respect to the output and time, in the left hand side we are integrating with respect to the output. So we have integral of io to I out di, which is equal to, we are integrating with respect to the time 0 to t seconds, that is ki into e into dt. So where e is the error signal and ki is the proportional integral constant, where dt is the change of time. So when you integrate this, it becomes I out minus io, which is equal to 0 to integral of 0 to t ki e dt, where io is the controller output of 0 time and I out is the controller output at the time of t. So here we have a few advantages because of the integrating this. So the ability of returning to the control variable to the back to the set point value is uh, possible with this integral control. So that is why this controller is also called a reset type of controller. So because of this, we can use this integral controller as alone as an integral controller, or we can combine with this some other controllers, that is pi. If you combine with the proportional controller, it becomes proportional integral controller, or if you combine with the proportional and derivative controller, it becomes PID controller, proportional integral and derivative controller. And these are all the references for my presentation. Mechatronics by W. Bolton, published by Pearson Education, second edition in the year 1999. And the second reference is Mechatronics authored by Bradley uh, and published by Chapman and Hell in the year of 1993. So in this lecture series video, we have discussed about the integral mode, then how the integral can be possible, and the mathematical equations for the integral mode, and few applications of the integral mode, and few advantages and disadvantages of the integral model. So I hope this video is useful for you. Thank you for watching this video.